Hi everyone, welcome to the Laser Channel. My name is Greg and this is the second video in a series featuring the Hydbond family of products. Welcome back. In this video, I'm going to show you how to use this blue Hydbond Leatherette with the silver undertone using a 40-watt CO2 laser machine and then applying that patch using a Vevor hat press. Hydbond also offers their blue Leatherette material with a black engraving that shows through. I'd recommend that if you're new to lasers and new to making patches, to start out with the color Leatherette that has the black engraving that shows through. The settings that you'd use for this are a lot more forgiving. In a little bit, I'm going to be jumping into Hydbond software. I'm going to show you the settings that I'm using to get really nice engraving on this material. But what I really want you to focus on is how I'm generating those settings that I'm using. Especially when we're working with CO2 laser machines, there can be a lot of variations from one machine to another, including how old the laser tube is, how old the power supply is, what types of mirrors you have, are they clean, what type of focusing thing. And all of this means that you might not be able to take the settings that I'm using and get the exact same results. That's why it's going to be important to learn how I'm generating my settings. So with all of that covered, let's jump right into it. The first step in making a hat patch with the Hydbond Leatherette material is finding some settings that work with your machinery for the engraving and the cutting. And for that, when I'm in Hydbond software, I use a test pattern. And when I start out with a new material, I'm not really sure what to do. So I start out with settings that have a kind of a big span. And by that, I mean that I start out at a low speed and I end at a very high speed, and I start with a power level where my laser machine will just start to mark and go up to a fairly moderate power level. I've already made my test samples, and let's take a closer look at that. On my first test sample, I started at a speed of about 50. I went up to 150 millimeters per second and a power level of 15, and I went up to 35%, and I'm just trying to engrave, and we can see I burned all the way through. And what I'm trying to do with the laser is just kind of scratch the surface to get that silver undertone to show through. I very quickly found out that it does not take a whole lot of energy power to go through this top blue layer. When I moved on, I reduced the power level range. I went from about 12% up to, I think that's about 20-something%. And I kept the speed about the same, and I just started to get some settings that looked good. This whole column here didn't even make a mark, so I focused on my settings in this area. And when I kind of narrowed those settings in, now here I've got something that looks good. Down in this corner, I still have some of this blue material attached. And up here, that doesn't quite look too good. But this little band right here of this square, and this one looks pretty good. So I can take the power level, the speed here, and the power level down here, and figure out that that's a pretty good setting. Once I have my engraving setting, I can go over to my cut settings, and here I'm running a speed of 25 millimeters per second, and I ranged from about 25% power up to about 60%, I believe. And then off to either side, you can see where I did the test samples before making this video. One of the interesting things that I found when I made my test samples are the engraving squares that look the best. When it first comes out of the laser machine, it will still appear slightly blue, and this is some of the leftover residue from this top blue coating. And the best way that I found to clean this off is to use this product. It is called LA's Totally Awesome. It can be found at the Dollar Tree, or if you like to spend more money, you can find it on Amazon. I tried using denatured alcohol on a previous project to clean the surface, and that is definitely not the material to use. Before jumping into Lightburn to show you where you can generate those test squares, I just wanted to share with you that this Hydbond Leatherette material comes with the Hydbond adhesive already attached to the back. You can also purchase that adhesive on a roll stock, and I'll show you a close-up of what that material looks like on this little square that I cut from another piece of material. Here's that little square. I've got the release liner pulled back a little bit, and this is the heat activated Hydbond. And when I pull on this, this stuff is incredibly strong. And once it's properly heat activated to your material, I mean, this stuff is really attached. All right, let's jump into the computer, open up Lightburn, and take a look at where you can find those test grids to get your perfect settings, and then I'll show you the graphic that I'm going to be using. Inside Lightburn software, I can navigate to the top of the screen to Laser Tools and Material Test. And this is what I use anytime I place a new material in my laser machine and I'm looking for some settings that are really going to work for my setup. I now have the graphic loaded in Lightburn that I'll be using for this project, and to get the correct sizing of my graphic, I'm going to take the hat that I'll be using and take a measurement. 2¼ inches will look perfect. That's also going to cover up the mark from the previous patch that was on this hat. Yep, I'm recycling a hat because this is what I have available, and normally I wouldn't match a blue patch up to a yellow hat, but this is just to demonstrate the process of how to use the Hydbond material and find great settings for your project. Here I'll hit Control-A to highlight everything, and now I will type in that 2¼ inches. That looks great, and I'll zoom in on that, and we'll see for the fill layer for the engraving, I have a speed of 175 millimeters per second at a power level of 15%. I will have the air assist on, and I do have constant power mode activated, and my lines per inch is set at basically 300. I do have bidirectional fill on, and I do not need crosshatch on. This looks good, and I can close this out. And the next layer is this blue layer, and this is what I'm going to use to cut the patch out of the material. And this, I'm running a speed of 25 millimeters per second at a power output of 40%. And I'm going to do 2 passes with this. Normally, if I had honeycomb underneath my material, I'd only need to do 1 pass, but because, as we'll see in a minute, how I have the material set up in the machine, I do need to make 2 passes. I've got my graphics set in Lightburn, and I have some great settings from that test sample sheet from the materials test earlier. And that's now time to cut off a little strip of this material and get that set up in my CO2 laser machine. Now there's going to be a really crucial step in that you won't want to miss. We're taking a look at my Monport 40-watt CO2 laser machine. I do have an air assist kit installed on this machine, and that moved the focusing lens up a little bit, so I found that I usually need to take some material and space up my work material up to bring it into proper focus. Here's that Hydbond Leatherette material. When I place this down and I take my focusing gauge, and this is going to be absolutely crucial in this project, is we'll see that I have a gap in there. I have the laser head defocused by about 0.17 inches. Feel free to use a setting of defocused of about 0.1 to 0.2 inches. I found that when I was doing my test materials engraving, that if I kept the laser perfectly in focus, it was just so difficult to find a setting to engrave through the blue surface, but not all the way through the silver layer underneath it. It's not until I move the laser up a little bit, or in this case, pushing my work material down a little bit to defocus the laser, that now I have a little bit more settings to play with that I can easily engrave through the blue layer and not burn all the way through that silver foil directly underneath. In this first setting, that's exactly what I had. I had the laser perfectly in focus, and it was just too difficult to find a good setting. And it's not until I did that defocus laser head that I could start getting some nice, clean, consistent results. And by the way, when I did my test cutout pattern, I left the laser defocused, and there's still plenty of energy to turn the laser up in power and get a nice, clean cut through. This looks fantastic. I'm going to get the computer hooked up to the machine. I'll frame everything out to make sure that the laser head travels over the work material, and I'll be ready to hit the start button. The engraving's complete and the smoke is cleared, and let's take an initial look at this. Here I've got a nice clean cutout of this patch. We'll see on the engraving area that it still has this blue residue, but don't worry, that's normal and it will look like that. Using LA's Totally Awesome Cleaner, I'm going to start out by just pre-soaking the top surface just a little bit, and then applying some of the cleaner to a clean white paper towel. I like to use the white paper towel so that I can see the residue as it comes off. And you'll see immediately that blue residue that was left over after the engraving comes right off. I like to scrub just a little bit extra just because I like to be very thorough that I'm removing all of the residue off of this patch. I love this border that I put around the logo, and even though we defocus the laser quite a bit, I still have all of this clean, crisp detail all throughout this engraving. I spoke with Josh, one of the co-owners of Hydbond, and to properly activate the Hydbond adhesive, he suggested getting the Hydbond adhesive up to at least 220 degrees Fahrenheit for a minimum of 10 seconds. So in a minute, we're going to take a look at the settings that I have on this hat press. But first, I'll turn the power on and let this get up to temperature. While my heat press is coming up to temperature, this is a great opportunity to share with you that while I was doing my test patterns to find my cut settings and engrave settings, to finally test that out, I did some small little project samples off to the side here, and I used those sample pieces to go onto a donor piece of cloth. This is just some old blue jean material, and I used this to fine-tune my heat press settings to the patch that I'm using. We'll see in just a minute when the hat press is up to temperature that the temperature I'm using is much higher than the suggested 220 degrees F. There's two reasons for that. The first one being is that I will have a piece of Teflon over the top of this, and to compensate for that, I will need to add about 5 degrees of temperature. The other part of that is my hat press, when I first got it, I put a temperature probe in between the mat down at the bottom and the heat platen, and I found that the heat press was off by about 30 degrees. So whenever I have something that has a suggested activation temperature, I automatically add 30 degrees on top of that. And the last part is generally you will have to drive a little bit of extra heat into your material because remember, the adhesive activates at 220 degrees. However, you have to drive all that heat through the patch that's on top of the adhesive. Moving on to the time duration to activate it, and again, Josh suggested a minimum of 10 seconds, and I'm running about double that at 20 seconds. And again, that is to give the heat press time to drive the heat through the top of the patch into that Hydbond adhesive. On my heat press, the top readout is going to be the actual temperature, and the bottom readout is going to be how many seconds that the heat press will go. When I close mine, it activates a switch and it automatically starts doing a countdown. When it reaches 0, it starts beeping until I open the heat press again. To check out the actual set point, I'll hit the temperature button on mine, and we'll see that my temperature that I have entered in is 265 degrees Fahrenheit. We'll see that I'm reading 270 degrees right now, so I'm going to give my heat press about another 5 minutes for it to continue to stabilize that temperature out before I attempt pressing the patch onto the hat. It's been several minutes and now my temperature has stabilized out to an exact 265 degrees. Well, notice that the rubber mat that I have on my hat press, I removed the blue one that came with the machine. It's just far too wide and it needs to be a lot narrower. Otherwise, I found that I got wrinkling on my hats. So the first thing that I like to do is fold down this bottom inside band of the hat so it fits into the press properly. And I'm going to press down on this lever, and that lever holds the hat down firmly in place. Everything's all set correctly. And what I like to do is when I think I've got it set in place, is I like to push down on the top of the hat, and I don't want to see the hat deflect or bubble down too much. If it does that, that'll actually wrinkle the hat material, and when you close the press, it will iron in some of those wrinkles, and a lot of people have that with this type of hat press. And I always like to pre-press to pre-warm up my hat a little bit. So for that, I place a piece of Teflon over the top, and I'm going to close this down just for about 5 seconds or so. All I want to do is get the hat pre-warmed ever so slightly. Now I can take my hat patch, remove the liner, and place my patch exactly where I'd like to on the hat. If I'm concerned about the patch moving in the final moments of the press closing, I can take some of this heat transfer tape, it's also called Kapton tape, and I can place that over the top. And a little trick that I watch by watching other YouTubers is I don't have to cut the tape off. I'll just leave this dangle, and when I'm done tacking the patch onto the hat, I can roll this tape back up onto the roll. For this next part, all I'm going to do is close my heat press again, just for about 5 seconds. All I'm trying to do is just tack the patch down just a little bit. If I left the press closed for the entire duration, what I found is this heat press tape will leave a mark across the patch, and I definitely don't want that. So already, just that short duration, I was able to tack the patch onto the hat. And I'll place my Teflon back down, and here I'll apply the heat for the full 20-second duration. There we go, we're all set, and I'm going to carefully peel off the Teflon. And the hat is ready to be handled right away. However, I don't want to pick at the patch until it's been several minutes and that patch, the adhesive, have fully cooled. In this second video of the series, it was really nice to be able to use a CO2 laser machine to engrave and cut out the patch, along with using a proper heat press where I can set the temperature to an exact amount, and I have a timer to know exactly how long I've been heat pressing the patch. If you've watched the first video in this series, you'll know that I used an X-Tool laser diode machine to make that patch, where I then heat pressed it onto a piece of sample denim cloth. For the heat press in that video, I used a regular clothes iron, and while it worked, it's a little bit unknown exactly the temperature that I'm heat pressing the patch on, And then I've got to use a cell phone or a watch or something as a timer for the amount of time I'm applying that heat. So definitely a step up using the speed and power of a CO2 laser machine along with the nice benefits of a proper heat press. Join me in the next video when I swap out the CO2 laser machine for a crazy fast, crazy powerful fiber laser to engrave and cut out the Hydbond Leatherette patch. I'll then be using a very nice garment heat press to press that patch onto an article of clothing. I hope that you enjoyed this video. If you did, please consider liking this video, subscribing to the channel, or ringing that notification bell. It definitely helps the channel out, and it's a great way to connect content like this with other viewers just like you. Until next time, learn, create, and share.